Hello, and in this video we will be having a look at A-level physics specifically for EDEXCEL. We'll take a look at real and virtual images, the thin lens equation, and the magnification of an image in this video. So specification point 78 states that we need to understand that for thin lenses in combination, the total power is given by the power of each individual lens added together. Specification point 79 states that we need to know and understand the terms real image and virtual image. And specification point 80 states that we need to be able to use the equation 1 over u plus 1 over v equals 1 over f for a thin converging or diverging lens with the real is positive convention. And specification point 81 states that we need to know and understand that the magnification of an image is given by the image height divided by the object height, which is expressed as m equals v over u. So, if you have two or more thin lenses in a line with their principal axes lined up, if the lenses are touching or very close, then the total power of the lenses is given by adding all the powers together. And it's important to note that the images formed by a lens can either be upright or inverted, magnified or diminished, and real or virtual. That third bullet point is important, as I'll get onto it in the next slide. So, a real image is formed when light rays converge onto a given point, as in the case of a convex lens. And a real image would be an image which can be captured or projected onto a screen. So as we see on the following diagram on the left hand side, it shows a picture of a converging lens. We have our parallel rays of light entering into the lens, and basically those light rays then refract and converge onto a given point, which is referred to as our focal point. And there is a vertical dotted line going down the center of our converging lens, and that would be referred to as our lens axis. And the distance between the focal point and the lens axis is referred to as the focal length. Now, if we move on and have a look at virtual images, basically a virtual image is formed when the rays of light appear to meet behind the lens when traced back from the diverging rays. Now, it's important to note that a virtual image cannot be projected onto a screen. So as we can see on the right hand side, it shows a picture of a diverging lens. So we initially have our rays of light parallel entering into the lens, and as a result they refract and diverge outwards. And what we need to do is we need to use virtual dotted rays and trace them back from the diverging rays, and at the point where each and every single virtual ray converges, that would be referred to as the focal point, which would be the point at where the image is formed, which is behind the lens. And yet again, the distance between the focal point and the lens axis of a diverging lens is referred to as the focal length. And moving on, we need to have a look at the thin lens equation, which is given by 1 over u plus 1 over v equals 1 over f, with u being the distance between the object and the lens axis, v is basically the distance between the image and the lens axis, and f is the focal length, which is positive for real images and negative for virtual images. So, we also look at the magnification of an image, which is given by the image height divided by the object height, and since magnification is a ratio, it has no units. And we'll have a look at a series of questions in the next slide. So, question 1 states that the length of a straw is 300 millimeters. The lens is placed in front of the straw so that the principal axis of the lens is parallel to the straw. An image of the straw is projected onto a screen, and the image has a length of 50 millimeters. So part A states that we need to calculate the magnification. So the magnification is given by the image height divided by the object height. The image height is 50 millimeters, the object height is 300 millimeters. We do 50 divided by 300 and we end up with 0.1666 reoccurring. Part B states that if the straw is 10 millimeters from the lens, calculate how far the screen is from the lens. So now in this case, we make V the subject of the formula, which is equal to the product of m times by u. So basically we have V equals 50 over 300 times by 10, and we get an answer of 1.66 millimeters. For part C, it asks to calculate the power in diopters. So basically the power is given by 1 over u plus 1 over v, which is equal to 1 over f. So we need to convert millimeters into meters, as that's the standard units that are used for the equation for a thin lens. So we convert 10 millimeters into meters, that gives us 0.01 meters, and we convert 50 millimeters into meters, which gives us 0.05 meters. And basically Doing 1 over 0.01 plus 1 over 0.05, that gives a total power of 120 diopters. Now part D states that another lens is placed in front of the first lens. The focal length of both lenses combined is 0.33 centimeters. Calculate the power of the second lens. So we use our power formula, which is basically 1 over the focal length, but before we do that, we need to convert the focal length from centimeters to meters. So we just do 0.33 divided by 100, and therefore we get an answer of 3.3 times 10 to the negative 3 meters. And then we substitute in the focal length into the formula, so we do 1 divided by 3.3 times 10 to the negative 3 meters, and we get a total power of 303.03 diopters. And then we go on to use the power formula for lenses in series, which is given as the total power equal to P1 plus P2 plus P3 and so on. Now because in this case there are only 2 lenses, we need to make P2 the subject of the formula, so we do P2 equals the total power minus the power of the first lens. The total power is 303.03. The power of the first lens is 120, so we do 303.03 minus 120. And the power for the second lens is given as 183.03 diopters. Thank you all for watching. I hope this video has made sense and cleared any questions anyone's had on lenses, especially with real images and virtual images and looking at the thin lens equation, as well as the magnification. Thank you all for watching, and goodbye.